All right, we're on our second day of factoring. Okay, we're going to move this up. And what you need to look at today is the sum and difference of cubes. And so before we had a difference of squares, where it was a squared minus b squared. Now you're going to be able to hopefully recognize if you have a cubed plus b cubed, a cubed minus b cubed. And this is the way you factor them. So for our first example, we have x cubed minus 8. That would be a difference of cubes because the cube root of x cubed would be a. So a is going to be the cube root, in this case, of x cubed. Or if you remember, that's also x cubed raised to the 1/3 power. And if I'm power to power multiply, we realize that the cube root of x cubed is x. B is the cube root of 8, which is 2. So now we have our a and our b, and we just follow this pattern. If we want to factor x cubed minus 8, then I have a minus b, which is in this particular problem would be x minus 2. Then we have a squared, so that's x squared for this problem, plus a times b, so that's 2x, plus b squared is 4. And that would be our factored difference of cubes. Now let's check it. To check it, we're going to distribute this x to each of these and multiply. So we're going to have x cubed minus 2x squared, plus 2x squared, and plus 4x. Now we're going to distribute the negative 2 to each of these elements. So we have minus 2x squared, minus 4x, and minus 8. And you notice that these are going to add to be 0, so we're just left with x cubed minus 8. And so knowing that our factors multiply back to give us our original problem, we know that this is a valid factorization for a difference of cubes. Now it could be a sum of cubes. If it's a sum, if there's a plus sign, then you factor it this way. You need to memorize these. These are not going to be on the test. You need to commit these to memory. Okay, looking at this, we can't take the cube root of 54 and 128, but we can factor out a 2. So our first thing we're going to do is factor out a 2, and that'll leave us with 27x cubed plus 64y cubed. And when we do that, now we notice this can be factored as a sum of cubes. So our a, the cube root of 27 is 3, and the cube root of x is x. X cubed is x. Our b in this particular problem would be 4y, cube root of 64, and the cube root of y cubed. So now let's look at our pattern. We have 2 times, we still need the 2 because that's part of what we factored out to get to our original. A plus b, so we have 3x plus 4y. Again, we're looking up here, right here, at our sum of cubes. The next parentheses is a squared, which is 9x squared, minus a times b, so that's 12xy, and plus b squared is 16y squared. And that would be our factored answer. For the difference of cubes, or the sum of cubes. If you could factor this further, then you need to do that. Okay. Now look at this, cube root of 8, so we're going to find our a. Cube root of a is 2, cube root of x to the 6th is x squared, and the cube root of 125 is 5. It's a difference of cubes, so my answer is 2x squared minus 5 times 2x squared plus 10x squared plus 25. Okay. And that's our final answer. If we could factor anything more, we need to do that. Okay. On this next one, we have a sum of cubes. We can factor out a 5. And that leaves us with 3x squared. Well, it's actually not a sum of cubes. I spoke out of turn. We need to look at our greatest common factor first, which is 3x cubed plus 1. Now, this is not a sum of cubes because we can't take the cube root of 3. So this is the best we can do on this factorization. Okay. So that's the best we can do on that factorization. All right, we're ready to move to the next page. Okay. This part we're going to look at, let's review. If you notice this, no greatest common factor, but it is a difference of squares. We can take the square root of each term. So that would be x squared minus 9 times x squared plus 9. And then we can factor this again. X squared minus 9 is x minus 3 times x plus 3. And we still have the x squared plus 9. And that's our answer on there, on that one. Okay, here, greatest common factor, that's the first thing. And notice this flow chart that's on these notes. Look for greatest common factor first. So we have a 3, and that leaves me with x to the 4th minus y to the 4th. Now we have a binomial. If there are two terms, can we factor it as a difference of squares, a sum of cubes, or a difference of cubes? This could be a difference of squares. So that's 3 times x squared minus y squared times x squared plus y squared. And then we can further factor this x squared minus y squared is x minus y times x plus y, and we still have x squared plus y squared. And so break these down as much as you can when you factor. Here we have a greatest common factor of 16x squared. So I'm going to factor out 16x squared. And that's going to leave me with x squared minus 2. This is not a difference of squares. So this is the best I can do on this factorization. X to the 4th minus 49. Again, we can see a difference of squares pretty quickly. X minus 7, x squared minus 7, excuse me. X squared plus 7. The only one I could possibly have is a difference of squares here, but I can't take the square root of 7. So I'm finished at this step. Now moving it up, you can see the last step is check that nothing else can be factored. If there are 3 terms, factor mentally, factor using a process. The process we used a box, and we used grouping for that. Okay. That's a U. Grouping. If there are 4 factors, factor by grouping. Okay. So, and then last step, always check that you can't factor another step. Ideally, you'll get down to all linear terms, but you may not make it that far because you can't in some cases. All right, we will come back to starting rational functions and getting away from factoring next time.